Hello math students, this is Justin, and today we're going to talk about the squeeze theorem and how it relates to the limits of infinite sequences. Let's say that we're given three sequences, a of n, b of n, and c of n, where we know that for any value of n, a of n is less than or equal to b of n, which is less than or equal to c of n. Let's say that we know the limits of a of n and c of n. And for both of those sequences, as n goes to infinity, the limit is L. Well, then we know that the limit of b is going to be the same thing. As n goes to infinity, the limit of b will also be L. Let's take a look at how that looks so that we can better understand this. So here we're going to graph a of n, b of n, c of n. So we're going to start off with a of n. So we have a1, a2, a3, a4. Notice that our function's decreasing, and it's going to approach a limit at L, right here. So we could say that the limit of a of n equals L. Well, now remember, our condition was that a had to be less than c for all values. So here we're going to plot c of n, and notice that c is greater than a, so a is less than c, and c is also going to approach this limit of L. Now we know that b is between c and a, so what's going to happen, and why it's called the squeeze function, notice how c and a, their values get closer together as n increases. So that means b is going to get squeezed in between c and a until they both approach the same limit. So we know that the limit for b of n must also be L. And notice how the values for b in our sequence were squeezed in between c and a to reach the same limit. Let's look at one example. So a of n is going to be 0 to the nth power. B of n is 1 minus cosine of 1 over n. And c of n is 1 divided by n to the second power. So our condition to apply the squeeze theorem is that for all values of n, a of n must be less than or equal to b of n, which is less than or equal to c of n. So let's test a couple values to see if this is true. Well, for the first term, a of 1 is 0, b of 1 is 1, and c of 1 is 1. So we're fine there because b and c can be equal to each other. And then for the second term, great, we still have a is less than b, which is less than c now, so it's still holding true. And it also holds true for the third term. So we've just demonstrated that this pattern is going to continue, so we can apply the squeeze theorem, and we know that the limit of 0 to the nth power is 0, and the limit of 1 divided by n to the second power is 0, so that means the limit of b is going to be squeezed between a and c, and it will also have a limit of 0. And that's how you can apply the squeeze theorem.